Hey everyone, welcome to our official start of remote learning. Right? This is going to be a little different for everybody, but the important thing is to just keep that communication open and ask questions. All right. I miss you guys. I know that you miss seeing my face every single day, so I wanted to give you a little glimpse of that here down in the corner. I am going to make myself disappear though as I go through this video. So first thing I want to talk about is calculator. I know probably not everybody has a graphing calculator, a fancy calculator at home, so here's a few free apps that work really well. If you have an iPhone, you can search calculator 84 and find this icon. It looks really similar to the graphing calculator we have in class. If you have a Droid, Wabbit EMU for this icon. Again, it looks really similar to the calculator we have in class. And then another one that you could use works for both iPhones and Androids. It's called Graphing Calculator X84. It's got an icon that looks like this. These first two look a little bit more like the calculator we use in class, but this one looks very similar as well. And all three of these would work really well for our remote learning portion here. All right. So the next thing I want to talk about is as we are going through these videos where I'm teaching a lesson, you got to take notes. Okay. You don't have to write everything down that's on the screen, but you do need to try to write down most things. Okay. You want to write down any formulas or any examples or any definitions. And remember, you can pause the video. Okay? That's a really nice thing about remote learning. You can pause the video and jot things down. Now, every time that I do give you a video to watch, your grade will be to upload a picture of your notes from the video to Schoology. Right? I know some of you don't take a lot of notes in class, but you really need to get in the habit of doing it. Okay? Even if it's something that makes perfect sense in class and you get it right off the bat, just writing it down helps you remember it further down the line. So let me show you on Schoology where you are going to do this. Okay? If you go to our honors geometry class, I've created a new remote learning folder up at the top here. So if we open this up, there's the Google Doc that I sent you in the email is right here. And then also every week I'm going to have a new subfolder here. So this first week we're going to have 4 assignments. The first one is our 9-5 notes. So if you go into this assignment, over here on the right is where you can submit. It doesn't allow me to show you the actual button, but it's going to be over here where you actually submit your picture of your notes. And you can just snap a picture with your phone and upload it. And you can also do this on the Schoology app. Right? If you're taking pictures with your phone, it might be easier if you download the Schoology app and use the app to upload your picture into this assignment. All right. So if you have any problems with that, any questions, just send me an email or a remind message. All right. So let's go ahead and get started with the lesson then. All right. So we are talking about tangents in section 9.5. Right, we're picking right up where we left off. We covered the first 4 sections in this chapter. So now we're on to 9.5. So this section, right, we're talking about tangents. Now a tangent, in terms of a circle, is a line that intersects the circle in exactly one point. Exactly one point. And that one point is called the point of tangency. Kind of makes sense, right? Now there's 2 properties that we're going to look at and use these to solve problems in this section. All right, so I guess over here first in this picture, the line SR and the line ST are both tangents because they hit the circle at exactly one point. They just kind of glance off the edge. And we could even extend this line out and it would just hit the circle at that single point. Now the first property we're going to look at is that a line is tangent to a circle if and only if it is perpendicular to a radius at a point of tangency. So in this figure over here, since SR is tangent to the circle, that automatically means that this is a right angle. Right? That automatically means that PR and SR meet at a right angle. The other property that we're going to use is that if two segments from the same exterior point are tangent to a circle, then they are congruent. Okay, so I would jot those definitions down on your notes. Right? So in this figure over here, that means that since SR and ST are both tangent to the circle and they originate from the same point, they're congruent. They have the exact same length. So if SR is 10, ST is also 10. They're equal. They have the same length. Right? So let's take a look at a couple of problems that deal with those properties. Right? In this first example, we're told that AB is tangent to the circle. So that means that that's a right angle. Right? My goal then is to find x. So what we're doing is looking at this right triangle. Right? Well, what we're given here is that the length of BC is 8, the length of AD is 9, and then AB is what we want to find. Well, one little trick that we used in previous sessions was we know that any radius is the same length. So if BC is 8, DC is also 8. So that means this entire side of this right triangle, which ends up being the hypotenuse, is 9 plus 8, it's 17. Right? So this entire side length is 17. Now we're going to use the Pythagorean theorem. I know two sides of a right triangle. I want to find the third. So remember, in our a squared plus b squared equals c squared, a and b are the two legs. So 8 and x would be my a and b, and then the hypotenuse is c. So I'm going to have x squared plus 8 squared equals 17 squared. So just solve this for x. And subtract the 64 over. Oops. Minus 64. X squared equals 225. And then we'll take the square root, and this is a perfect 15. So x, this missing length here, is 15. Right? So using our new property that a tangent line, which is a line that hits the circle in one point, has to be perpendicular to a radius, we were able to use our properties of right triangles and use the Pythagorean theorem for this problem. Right? Let's take a look at another example. On this one, we know that CB and CD are tangent to the circle. We're going to use our other property here. Since both of these lines originate from the same point outside of the circle, which is C, we know that they are equal. So my setup here is just going to be to set those equal to each other. All I need to do then is subtract 3 from both sides, and we get x equals 4. Okay, and that is my final answer. The problem just says find x. All right. So let's take a look at another couple of examples dealing with these ideas. All right, here's one. Okay, kind of similar to the example up top. Now, if you want, it would be a great idea to maybe pause the video at certain points and see if you can try these problems before you see me do them to make sure that you got this stuff down. All right, so go ahead and pause the video here and see if you can solve this one for x. All right, so just like in the first example, we know our two radii will have the same length. So if yz is 21, then ya is also 21. And the entire length of the hypotenuse then would be 21 plus 8 would be 29. So then we can use the Pythagorean theorem. Again, I guess I should have mentioned we know this is a right angle because the tangent and the radius are perpendicular. So A, B, and C, we will have a squared plus b squared equals c squared. So x squared plus 21 squared equals 29 squared. So I don't know these off the top of my head, so let's bring up the calculator. 21 squared is 441, so x squared plus 441 equals 29 squared is 841. Subtract the 441 over, we get x squared equals a nice round 400. Take the square root of both sides, and the square root of 400 is 20. So this missing side here, ZB, is 20. All right. Let's try one more like this. All right. Let's take a look at something like this. All right, so my x value is just this ut. Right? So there's a couple of ways that we could go about solving something like this. I'm going to show you two different ways. Okay, the first way, we could say, well, we know if our s is 15, our u is 15. So that would make the entire hypotenuse 15 plus x. So we could set it up like this. We could say 15 squared plus 36 squared. Again, I forgot to mark that that's a right angle. So these are my a and b, equals 15 plus x squared. Okay, I could write it like that. Well, then I can go ahead and square both of these values over here. So 15 squared is 225. Don't know what 36 squared is off the top of my head. 36 squared is 1296. So plus 1296 equals 15 plus x squared. Add those together. So plus 225, 1521. So 1521 equals 15 plus x squared. Now, what I can do here is just take the square root of both sides now. Okay? As long as I keep my parentheses here, I can take the square root of both sides. So the square root of 1521 is a nice even 39. So we end up with 39 equals, so we still get the whole thing that's inside of the parentheses here, 15 plus x. So now, to get the x by itself, I can subtract the 15 over, and we would end up with x equals 24. All right. Another way that we could have done this is just said, well, the whole hypotenuse is what I want to find. I know these two legs, and I could call the whole hypotenuse my variable. If we solved for the whole hypotenuse, we would get 39. And then we would just have to subtract 15 to get x. And that's what we did, right? To get that x is 24. Right? One other small idea here. Right? We can use our second idea here to talk about circumscribed polygons. Right? Now, a circumscribed polygon is just whenever we have a polygon that is outside of a circle and every single edge of that polygon is tangent to the circle. Right? So if we look at this figure over here, every single edge, or every single side, hits the circle at exactly 1 point. Okay, same thing over here. Every single edge hits the circle at exactly 1 point. All right? So the way that we can solve problems with something like this, okay, we can be given a few different pieces of information. In this example, they ask us to find the perimeter. Well, our property that we talked about earlier was that if we have two tangents originating from the same exterior point, they have the same length. So if BE is 6, that means BD is also 6. Well, down here we know F or CF is 8. That means CE would be 8. Then over here, if AF is 12, AD is also 12. So then to get the entire perimeter, we're just adding all of these values up all the way around the circle. So 12 plus 12 is 24, plus 8 is 32, plus 8 is 40, plus 6 is 46, plus 6 is 52. So the perimeter here would be 52. All right. Let's look at another example or two real quick here. So in this example, they say find x and find the perimeter. Right? Well, x, they're saying, is this entire length of this side of the triangle. But we want to use the same logic that we did before. Right? Two tangents originating from the same point have the same length. So if this piece is 10, this piece is 10. Well, that allows us to find the entire value of x then. Right? So here, x would be 10 plus 13, x would be 23. And then we can use our property to find the perimeter. So if this side's 13, that side's 13. If this piece is 17, this piece is 17. And then we can just add all of those together. So 10 and 10 is 20, plus 17 would be 37, plus 17 would be 47, 54, plus 13 would be 67, plus 13 would be 80. All right. One final example here. All right. We've got a circumscribed quadrilateral. So we know that this is 8. Well, that makes this 8. So to find x, we can just first say 2x equals 8. Divide both sides by 2, and we would get x equals 4. All right, so then we can use the logic the rest of the way around. All right, so we know this is 8, so that makes this side 8. Well, if this entire length is 16, that makes this 8. So that would make this 8. All right, so now we can see that this is going to be a square. Right? So we can end up filling out that this is 8 and this is 8. So the perimeter then of this square will just be 8 plus 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 8. So that's going to be 64. All right. So this is the assignment for today. Remember, now that you have your notes, just snap a picture and upload that to Schoology. Right? That's your grade for today, right? That you took notes on this video. Now, the assignment for tomorrow then is an edge elastic with some practice problems over this material. Right? So, and you can go ahead and complete that now if you want. You don't have to wait until tomorrow. But remember, all of this for this week, all right, for every week, is due by Sunday at midnight. Right? So make sure you get everything done no later than Sunday at midnight. But if you follow the guide that I've laid out, you're not going to get stressed or overwhelmed. You'll just have maybe a half hour of work every day. The big thing, though, is ask me questions. Right? If there's something that doesn't make sense, something you're struggling with, send me a question through email, on the Remind app. We can even set up a Google Hangout or a Google Meet if you want to meet face-to-face, and we can talk through some things. All right, but keep that line of communication open if you're struggling with something.